JEE Advanced 2025, Paper 2, Physics, Question 2. Let us first visualize the setup. We have two coaxial conducting cylinders of the same length L. The inner cylinder has radius √2 times r and carries charge q. The outer cylinder has radius 2r and is grounded. The annular region between them is filled with a dielectric of kappa equals 5. Now look at the cross-section. The inner circle of radius √2r carries charge q. The outer circle of radius 2r is grounded. The shaded annular region is the dielectric with kappa equals 5. An imaginary flat plane of length L is placed at distance r from the common axis, parallel to it. We need the electric flux through this plane. Here is the full question. Two coaxial conducting cylinders of the same length L, with radii √2r and 2r. The inner cylinder carries charge q, the outer cylinder is grounded. The annular region is filled with a dielectric of dielectric constant kappa equals 5. An imaginary plane of length L at distance r from the axis is parallel to it. We need to find the electric flux through this plane. The options are A, q over 30 epsilon naught. B, q over 15 epsilon naught. C, q over 60 epsilon naught. D, q over 120 epsilon naught. The key concept here is Gauss's law in a dielectric medium. The total flux through a closed Gaussian surface enclosing charge q in a dielectric of constant kappa is q over kappa epsilon naught. The electric field between the cylinders, in the dielectric region, is E equals q over 2 pi kappa epsilon naught RL. Since the imaginary plane is a flat surface, not a closed surface, we need to integrate E dot dA over the portion of the plane that lies in the dielectric region. Step 1. Identify the geometry. The imaginary plane is at perpendicular distance r from the axis. Since r is less than √2r, part of the plane lies inside the inner conductor where the electric field is 0. Only the portion of the plane that passes through the dielectric region, where r is between √2r and 2r contributes to the flux. Step 2. Set up the integration. Consider a point on the plane at height y from the closest approach point. The distance from the axis to this point is r equals square root of r squared plus y squared. The angle between the radial direction and the normal to the plane is theta, with cosine theta equals r over r. The electric field is radial, so E dot dA equals E times cosine theta times dA. Step 3. Evaluate the integral. The flux equals the integral of E cosine theta dA, substituting E equals q over 2 pi kappa epsilon naught RL, and cosine theta equals r over r, and integrating over the length L along z, the L cancels. We get qr over 2 pi kappa epsilon naught times the integral of the y over r squared plus y squared. This integral gives 1 over r times r tan of y over r, so the r also cancels. We get q over 2 pi kappa epsilon naught times the r tan evaluated at the boundary limits. Step 4. Find the limits of integration. At the inner cylinder, r equals √2r. So y1 equals the square root of 2r squared minus r squared, which is r tan of r over r equals r tan of 1, which is pi over 4. At the outer cylinder, r equals to r. So y2 equals the square root of 4r squared minus r squared, which is √3 times r tan of √3 equals pi over 3. Step 5. Compute the flux. For one side of the plane, the flux is q over 2 pi kappa epsilon naught times pi over 3 minus pi over 4. That is q over 10 pi epsilon naught times pi over 12, which simplifies to q over 120 epsilon naught. But the plane extends on both sides of the closest approach point, above and below. So the total flux is 2 times q over 120 epsilon naught, which gives us q over 60 epsilon naught. The correct answer is option C, q over 60 epsilon naught. This matches our calculation perfectly. Here are some important exam tips for JEE Advanced. Tip 1. For flux through partial surfaces, always set up the integration carefully. Gauss's law alone gives total flux through closed surfaces. Tip 2. Always check whether the surface or plane lies inside or outside the conductor, because E equals 0 inside a conductor. Tip 3. When a geometry has symmetry, remember to account for both halves. Here we multiplied by 2 for the two symmetric sides of the plane. Tip 4. The integral of the y over r squared plus y squared equals 1 over r tan y over r. This integral is very common in electrostatics problems involving cylindrical symmetry. If you found this helpful, Please like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.